Hi guys, greetings of the day. Myself Praneeth, and today I'll be explaining about solving of n queens problem using backtracking. Firstly, what do you mean by backtracking? Backtracking is a way of solving a problem in a step-by-step process, such a way that if a step is wrong or it cannot find a solution, it backtracks to the previous step and takes a different path for solving a problem. Okay, now what do you mean by n queens problem? Solving of n queens problem. Solving of n queens problem is placing a n queens in a n by n chessboard such that no queen matches with the same row or same column or same diagonal. See, this is a solution for a 4 by 4 chessboard queens problem. See, if you see this queen, it does not matches with any diagonal with the other queen or the row or the column. Yes. Now, what are the key points? A queen in a chess can move any number of squares horizontally, vertically, or diagonally. The goal is to find all possible arrangements where all queens are placed without threatening one another. See, for this, we have a computer solving problem, that is an algorithm to solve the problem, and I have made it in C. This algorithm is used to place a queen in a place such that in a kth row and ith column to check whether we can place it in a kth row and ith column. See, we'll be doing by using a for loop to check all the rows. First, we'll have a x, that is an array, represents x of j, represents a column number in the ijth row. This jth row. If x of j, that is a column number, matches with a uh, column, then that means they both are in the same column, so we can x of j represents the previous queen placed column number. So if the both column numbers are same, that means we cannot place it, then it returns false. And now these to check whether they are present in the same diagonal or not. ABS, that is used that is a function, not a function, uh, that is used to find the return a value such that it might be negative or anything. It returns only positive numbers, integers, that's it. X of j represents the column number and column number of the previous queen, and I represent the column of the present queen. And ABS of j represents the row of the previous queen placed, and k is the row of the present queen. If the both matches, then they belongs to the same diagonal, so we can't place that. If it fails to satisfy the both the condition, then that it returns the true value. That means we can place the queen in the kth row and ith column. See, for example, we have placed a queen in the first row and second column, and second row fourth column, as you can see here and here. Now we are checking to place a queen in the third row and third column, and that is this place. As you see in the diagonal, it has a queen, so it should not be placed there. See how we will check how it solves. See, using a for loop, we'll check for the all columns, right? First, we will take a first column, x of 1, that is the column number for the first queen. This is x of 1 equals to 2. But here in the new queen that should be placed, the column number is 3. So 2 is not equals to 3. So there is no objection with the column due to the first queen placed in the first row. Now for the checking in the diagonal, ABS of 2 minus 3, that is x of the column number of the first queen. First queen column number is 2, second column, minus the column number of the present queen, that is 3. 2 minus 3 is 1. And when it comes to this, in this the row of the first queen placed, that is 1, minus the row of the present queen should be placed, that is 1 minus 2 is minus 2. When we use ABS, that returns only a positive number, not negative. So 1 2 they are not equal. So with respect to the first queen, there is no objection of placing a queen in the 3 by 3, but we have to check for the queen placed in the second row also. So we'll increment the J value and checks according to the second queen, x of j column number is 4, that is not equals to the column number of the present. So according to column, it doesn't have any objection, but when it comes to diagonal, as you see, it is in the diagonal itself. Now x of 2, I mean column number of the second queen is 4 minus column number of the present queen, that is 4 minus 3 is 1, and this the row of second queen, which is the row number of the second queen, that is second row, and the row number of the present queen that should be placed is also 3. 2 minus 3 is minus 1, so it returns a positive number, that is 1. Here you can see 1 and 1, it matches. So as you see, it is present in the diagonal. According to the function also, it is present in the diagonal itself. So it returns a false value. So it cannot be placed in a third row and third column. That is for the checking to check the queen that can be placed in the ith column or ith row. Now this algorithm is used to find the number of solutions. In a 4x4 chessboard, we can have many solutions. To check it, we'll call a function n queens of k comma n, where k represent the row and n represent the size of the chessboard, that is n, for n by n, right, that n. See, for triangle of all columns, we use a for loop 1 to n. As we have discussed, we'll check the place that can be queen can be placed. Place of k comma I function will be called. If it is true, then it goes to the for loop and it gives the column number x of k. X of k means here first is x of 1. X of 1 equals to I, where column number is 1. For the first row, first column, we have put a queen, and we'll increase the I value, and after doing everything, we'll find many places to fix a queen. If k equals to n is the n by n chessboard, right? K is the row. If you have placed every queen in every row, then k value reaches to 4 in a 4x4 chessboard. If 4 equals to 4, then we have placed 4 queens in 4x4 chessboard, such that no queen matches with the same row, same column, or same diagonal. That means that is a solution for us. Then we'll print a solution. If in case we have placed only 2 queens or 3 queens in a 4x4 chessboard, that means it's not a correct solution. So we'll go to the second row and we'll try to find the solutions. This is the event. Okay. Now we'll trace it. I mean manual tracing. First we'll take a 4x4 chessboard, and first we'll try to put a queens in a first row, first columns, first row, second column, first row, third column, and first row, fourth column. First, when we put a queen in a first row, first column, see, this is the column ruled out, this is the row ruled out, this is the diagonal ruled out. In the second row, I have only 2 places left out to put a queen. I'll put here. After putting here, all the places are ruled out because of the diagonal and row and column cases. Only one is left. Okay, I have put a 2 queens and 1 place is left. I can put a queen there, and as of now I'll have only 3 queens in the 4x4 chessboard, but I have to put 4 queens, then it becomes a solution. So when I put a 3 queens, it's not a solution. When I put here it's not, I didn't get a solution. So I'll try to put a queen here. When I put queen here, these are the places which are ruled out due to the conditions. Only one place I have left out, and that is that. So now also I have put only 3 queens. So this is also not a solution. We'll go to the second case. They're putting a queen in the first and second column. These are the places ruled out, and I have only one place in the second row, sorry. When I put a queen in the second row, I have left out with 3 places. 1, 2, 3. Okay, I'll put a queen in the third row, first column. This. When I put it here, I'll only left out with this place, and I'll put a queen here. And I have 4 queens. 1, 2, 3, 4. So when I put a 4 queens in a 4x4 chessboard, then that will be my solution. Instead of putting, when I put a queen here, I got a solution. So I'll try another way. That according to the solution we put here also. So I won't put a queen here. I'll try to put here. When I put a queen here, and this is my resultant I got, and I have left out with only this place. So 1, 2, and 3 queens. So this is also not a solution. And the third case is putting a queen in the first or third column, and after putting there, in the second row I have left out only with this place. When I put a queen in this place, I'll have 3 places left out. These are the 3 places. I'll put a queen in the third row, fourth column. After putting a queen in the third row, fourth column, I left out with this place, and I'll put a queen there, and it is also a solution. Because I have put 4 queens in a 4x4 chess matrix with no column matching or row matching or diagonal matching. And when I put a queen here, I got a solution. I'll try to put a queen here. When I try to put a queen here, the resultant one is this one, and I have left out only with this place. If I put a queen there also, I'll get only 3 queens in a 4x4 chessboard. So that is not a solution. And the fourth possible way is putting a queen in the first and fourth column. Okay, now I have 2 places left out in the second row. I'll put a queen here. When I put a queen here, I have 2 places left out, and those 2 are diagonal places. So if I put a queen in either of the places, I can't put a one more queen. So I'll be left out with only 3 queens. So that's not a solution. Okay, when we put a queen here, we didn't get a solution. We'll try to put a queen here. When we put a queen here, this is the possible way, and I have left out only with one place. Now, if I put a queen there, I'll get only 3 queens in a 4x4 chessboard. So this is also not a solution. I hope you have understood my explanation. Thank you.